Good morning, everyone. I am Sirisha Adam. Currently, I am studying Computer Science Engineering from Sri Siddheshwar Women's College of Engineering, Solapur. This video is concerned on Engineering Mathematics M1. Today, I am going to share an important and interesting chapter that is linear algebra matrices. In this chapter, we will be focused on Cayley-Hamilton theorem. Cayley-Hamilton theorem says that every square matrix satisfies its own characteristic equation. That means if you find the characteristic equation of a matrix and they replace the variable lambda by A, then the equation will become zero matrix. The characteristic equation is determinant A minus lambda I equals to 0. Here A is the given matrix, lambda is a scalar and I is the identity matrix of order n. If A is the 2 by 2 order, then identity matrix is also 2 by 2 order. If A is the 3 by 3 order, then identity matrix is also 3 by 3 order. On simplifying this characteristic equation, we get lambda cube minus s1 lambda square plus s2 lambda minus determinant A equals to 0. Here, s1 is the sum of the diagonal element. That means the diagonal is a11, a22 and a33. The sum of the diagonal is a11 plus a22 plus a33. It gives s1. Here S2 is the sum of minor of diagonal elements. It means minor of A11, minor of A22 and minor of A33. Here this sum this give S2. There are three types of questions asking in the exam. And we also say there are three uses of Cayley-Hamilton theorem. That is to verify that theorem, to find the A inverse of the matrix, and to find the higher powers of the matrix like A square, A cube and A raised to 4, etc. I have taken an example to understand the Cayley-Hamilton theorem and I am going to explain three types of question in one question. That is to verify the Cayley-Hamilton theorem. It is the first question and find A inverse. It is the second question and A raised to 4 of the given matrix. It is the third question. The matrix is given in the question. Let the matrix is become A. That matrix is 7, 2, minus 2, 6, minus 1, 2, 6, 2, minus 1. The solution is find the characteristic equation of the matrix. The characteristic equation is given by determinant A minus lambda I equals to 0, where A is the given matrix in the question and I is the identity matrix. The given matrix is 3 by 3 order, then the identity matrix is also 3 by 3 order. Solving the characteristic equation, we get 7 minus lambda, 2, minus 2, minus 6, minus 1 minus lambda, 2, 6, 2, minus 1 minus lambda. On simplifying the characteristic equation, we get general cubic equation. That is lambda cube minus s1 lambda square plus s2 lambda minus determinant A equals to 0. This is equation 1. Here S1 is the sum of the diagonal, that is 7, minus 1 and minus 1. The sum is 5. S2 is the sum of minor of diagonal element. To find the minor of Aij element, you have to eliminate the row and eliminate the column of Aij element and write remaining matrix as it is and solve the matrix. We get minor of Aij element. For example, minor of 7. Eliminate the ith row and eliminate the jth row of 7th element. Remaining matrix write as it is. We get minor of 7. Same as for minor of minus 1. On solving determinant A, we get 3. All values S1, S2 and determinant A substitute in equation 1. In this equation, substitute all values, we get lambda cube minus 5 lambda square plus 7 lambda minus 3 equals to 0. In first step, we find the characteristic equation and get this type of equation. In second step, verify the Cayley-Hamilton theorem. To verify the Cayley-Hamilton theorem on this equation is replaced by variable a. The equation is a cube minus 5a square plus 7a minus 3i equals to 0. This is the second equation. Firstly, we calculate the a square and a cube. Finding a square is equals to a dot a. Here A is the given matrix. We find this matrix by using scientific calculator.
To find a square, we using scientific calculator. Firstly, we on the scientific calculator. Next, click 3 times on mode CLR. 1, 2, 3. You can see this type of screen. You click to mat. Again, you click shift 4 dimension A. The matrices will be 3 by 3 order. Then value of M is 3 and value of N is also 3. The mat A11 is 7, A12 is 2, A13 is minus 2, A21 is minus 6, A22 is minus 1, A23 is 2, A31 is 6, A32 is 2 and A33 is minus 1. Again you click AC, then shift 4, 3, mat. Again you click A, the mat A, then you find A square, click x raised to 2 equal. The value of A square is 25, 8 minus 8 minus 24 minus 7, 8, 24, 8 minus 7.
Now, next calculate a cube. To find a cube, we using a dot a square. The value of a is given in the question and the value of a square is right in the above. Put here and solve by using scientific calculator.
To find a cube, we continue this calculation. Click AC. Again you click shift 4. You click 3, 1, shift. So mat E11 is 79, mat E12 is 26, mat E13 is minus 26, mat E21 is minus 78, mat 22 is minus 25, mat 23 is 26, mat 31 is 78, mat 32 is 26, mat 33 is minus 25.
By using a scientific calculator, we get a cube. Now substitute in the characteristic equation. The characteristic equation is a cube minus 5a square plus 7a minus 3i equals to 0. All values put in this characteristic equation, we get this matrix. This matrix says the Cayley-Hamilton theorem is verified. Step number 3, find the A inverse. From the characteristic equation, we have a cube minus 5a square plus 7a minus 3i equals to 0. Multiply by A inverse. To finding A inverse, this is note. The note is A dot A inverse is equals to high A raised to square and A inverse it gives AI. A raised to square into A inverse it gives A. A raised to cube into A inverse it give A square. Here A inverse dot A cube is give A square. A inverse into A square it give A. A inverse into A it give I and A inverse into I into A inverse. On solving this equation, we get this type of equation. All values put in this equation, we get A inverse. Calculate a raised to 4 by using a raised to square dot a raised to square. The value of a raised to square is given in the above. That is this. Put in here, solving each other by using scientific calculator, we get this type of equation. Hence, the inverse of the matrix is this, and the matrix A raised to 4 is this.